We will now use the concepts of the three laws of motion to solve problems. Now, in solving problems, we will follow some steps. Step 1, isolate the object or point on which the various forces are acting. Now, we will be looking at the forces acting on the object. And the net force is the sum of all the forces acting on the object. What is the net force equal to according to the second law of motion? The net force equal to mass times acceleration. So in order to find the net force, first isolate the object or point on which those various forces are acting, and if necessary, write the forces in the component form. Well, you know how to write a vector in the component form. Now remember, a vector has a magnitude and a direction. The direction is always measured with the x-axis. So if you have a force that makes an angle theta with the x-axis, its x component f sub x will be f cos theta, and its y component f sub y will be f sine theta. You know that, and we will be using this as we go on. So, if the forces are in the proper x and in the proper y direction, you don't need to do anything with it. But if the force is in an arbitrary direction that makes an angle theta with the x-axis, then write the forces in the component form as the x component is f cos theta, the y component is f sine theta. Therefore, f equal to f cos theta I plus f sine theta j. Alright. Third, apply the laws of motion and form equations. Well, F net equal to ma. That is the main law that we will be using to form equations. And finally, solve the equations for the unknown. This is the method we're going to use in solving all types of problems in this section. Alright, let's start with a simple problem. A stalled 1800 kilogram automobile is towed by another car with a horizontal rope, and the cars accelerate at the rate of 0.25 meter per second squared. Find the tension in the rope. So, when a stalled car is being pulled by another car using a cable, the tension in that cable is the net force. The net force to produce the acceleration is actually that tension force, and we are required to find that tension force. Alright, here is the stalled car. I think it is a 1969 Oldsmobile or something. Is that right? Looks like it. And it is being towed by the towing truck. And there's a cable there. You need to find the tension force on that cable. So we are looking for that tension force. The tension T on the cable is a measure of the force applied by the towing truck on the towed car. Now, the mass of the towed car, the old wreck, is m equal to 1800 kilogram. The acceleration produced on that car is 0.25 meter per second squared. So, an acceleration of 0.25 meters squared is produced on a mass of 1800 kilogram, and that can be done only by a net force. What is that net force? That net force is the tension on the cable. So it is a very simple problem. The net force needed to produce this acceleration is F net equal to MA, and that F net is the tension. So that tension therefore equal to MA, T equal to 1800 kilogram times 0.25 meter per second squared, and that will be 450 Newton. Okay, let's do another problem. A bullet of mass 1.8 times 10 to the negative 3 kilogram, moving at 500 meter per second, impacts with a large fixed block of wood and travels 6 centimeter before coming to rest. Assuming that the deceleration of the bullet is constant. Well, I use the word deceleration because it is a negative acceleration. I should have actually used the word acceleration because acceleration can be positive or negative. The bullet is brought to a stop, means the acceleration is negative. And find the force exerted by the wood on the bullet. Well, in order to find the force, we need the acceleration. Is that right? We have done this kind of problem actually before, calculating the acceleration. The bullet hits the block of wood with an initial velocity V0 equal to 500 meter per second. This is the block of wood, and see, you can see the bullet coming. The bullet came with a tremendous speed of 500 meter per second and hit the wood here. It is not stopped there. The moment it hits there, it has this velocity. V0 is 500 meter per second. And now it is going to go in and stop. Its velocity there is 0. The final velocity is 0. So when the bullet is at the front of the block of wood, its velocity is 500 meters per second. When it is brought to a stop, its velocity is 0. And what is the distance moved by the bullet in coming to a stop? Is 0.06 meter. This is that distance, 0.06 meter. Well, you have the initial velocity, final velocity, displacement. Can you calculate the acceleration of the bullet? What equation you will use? Now remember, all the equations of motion that we developed in Unit 1 are going to be used here. Without those equations, we cannot survive. So you must be familiar with it. We have the initial velocity V0, we have the final velocity Vf, we have the displacement x. The equation that describes that motion is Vf squared equal to V0 squared plus 2ax. Is that right? There is no time in there. So first we obtain the acceleration of the bullet from this equation. Vf squared equal to V0 squared plus 2ax. Vf is 0. 0 equal to 500 squared plus 2a times 0.06. Solve for a from there. I'm going to leave it for you to solve it on your own. I got a equal to negative 2.08 times 10 to the 6 meter per second squared. That is a tremendous acceleration. Negative means it is directed opposite to its velocity. So this is the acceleration. Now, we know that an acceleration can be produced only by an unbalanced force. Alright, tell me, what unbalanced force is responsible to produce this acceleration on this bullet? It is the force applied by the block of wood. Is that right? The block of wood will resist the movement of the bullet through it. In other words, the force applied by the wood on the bullet is directed opposite to its motion. So that is the net force. The negative sign indicates that the acceleration is opposite to the velocity. The bullet is moving forward. The force applied by the wood is in the opposite direction. That means the acceleration is opposite to velocity. The acceleration, this acceleration is caused by the net force on the bullet by the block of wood, which means F net equal to ma, and we are looking for that net force applied by the wood, and that will be mass of the bullet is 1.8 times 10 to the negative 3 kilogram. That is here, and multiplied with the acceleration, and we get that force is negative 3,744 Newton. Tell me, why is the force negative? The force is negative because it is opposing the motion of the bullet. The force is directed opposite to the direction of the velocity. Because we started by taking the velocity positive, the force is directed opposite to that. It is negative. Okay, let's do another one. A particle of mass 2.5